Hey, I'm really excited to dive into this topic with you. Today, I'm going to walk you through the process of setting matrix zeros in Python. Imagine you've got this cool matrix full of numbers, and a zero has somehow sneaked into every element of a particular row and column. Our mission, should we choose to accept it, is to ensure that this row and column are now just a big zero party. Sounds fun. Let's get started. First, remember that a matrix is just a fancy term for a 2D array. We are going to encounter these in many interesting problems, and mastering how to tweak them without losing sleep is a big plus. Before we roll up our sleeves, a quick refresher: each row in the matrix represents a data packet, and each column represents a feature of that packet. So when we zero entire rows or columns, we are saying something went wrong, and we should treat that row or column, the feature, as unimportant. Let's write the function. We'll start with our basic structure, a function to handle our matrix and identify the zero-ridden row and column. We are gonna name this set_matrix_zeros. Python is great because it makes all this feel like second nature. Python definite set_matrix_zeros. If matrix is none or not matrix, return none. If not matrix or not matrix, return z_i is equal to z_j is equal to none for I in reversed. For j in reversed, if matrix is equal to 0, z_i, z_j is equal to I. J break if z_i is not none, break if z_i is not none. For I in range, if I is equal to z_i, matrix is equal to z, else matrix is equal to 0 if z_j is not none. For j in range, if j is equal to z_j, matrix is equal to z, else matrix is equal to 0. Return matrix. Hang on here, we've done enough Python. It's time to discuss the details of the approach we used. At first glance, the code is straightforward. Find the first row and column with zeros, mark them, and fill other rows and columns with zeros. Notice the twist. Instead of marking with zeros or flags, we are using Z as a marker to avoid replacing zeros. That's an optimization we'll dive deeper into real soon. The reason for reversing the loops and breaking when we encounter the first zero is performance related. This technique speeds things up since we don't need to continue scanning after finding a zero. It's like not bothering to look for a missing sock once you've found one in the laundry. To kick things up a notch, let's optimize the matrix zeroing while saving memory. We want our script light and ready for large datasets without hogging memory. We use a single, in-place approach that skips non-zero elements effectively, minimizing the memory footprint. So, the journey continues with the next function, where we do just that and get into more nitty-gritty details. Python definite set_matrix_zeros_efficient. If matrix is none or not matrix, return none rows, calls is equal to lay hash first pass to count zeros 0_rows, 0_calls is equal to set for I in range, for j in range, if matrix is equal to 0, 0_rows dot add 0_calls dot add hash second pass to set zeros in place and keep track of changed rows hash and columns for later check. Changed is equal to set for I in range, for j in range, if I in 0_rows or j in 0_calls, matrix is equal to 0 changed dot add hash if a row was changed. Apply changes to all rows for that row. Row_changed is equal to I for I in range if any, for I in row_changed, for j in range, matrix is equal to 0. Return changed. Now, let's into a trickier part. Our function returns the indices of rows it changed to set their columns to 0. We are using sets instead of tracking with Boolean values. It's a small but smart tweak that keeps our data cleaner and our code tidy. With these functions in hand, you are equipped for any zero-ridden mess in matrices. But to wrap things up, we'll tackle the last piece of the puzzle, detecting just zero matrices without using extra space. If the matrix is a big O0, we should return an empty list early to save our precious resources. Now, doesn't that feel empowering? Python definite 0_ matrix. If matrix is none or not matrix, return rows, calls is equal to lay first_row_zeroed is equal to any, first_kernel_zeroed is equal to any, if first_row_zeroed or first_kernel_zeroed, return is equal to 0 else plus for I. In range, return now. This concludes our deep dive into optimizing matrix zeroing in Python. Before you go off and conquer any zeros in your datasets, remember to give your brain a well-deserved break. Take time to appreciate how elegant and efficient our little program is. Remember, when it comes to handling massive arrays, the right balance of time and space is key. I trust you are now confident to set any zeros in your Python journeys. Don't forget to visit neeraj.qzz.io and subscribe to Tech Vibes. I'll talk to you soon. Keep coding big. I hope you've enjoyed our chat about setting matrix zeros using Python. It's been fun, and I'm looking forward to our next session, whether it's about algorithms or just catching up on the latest coding challenges.